In this lesson, we will go through several examples of how to assign oxidation numbers to an element. Our first example is N2. This falls under our first rule, which is a free element has an oxidation number of 0, so nitrogen will have an oxidation number of 0. Next, we'll look at NH3. There is no rule that applies to nitrogen in this compound, so we will label it X. The rule for hydrogen is the oxidation number is +1, and we know that the sum of the oxidation numbers will equal 0. So we can say X plus 3 times +1 equals 0 because it's a neutral compound. X plus 3 equals 0, so X equals -3. If you're trying to set up an expression and find that you have two values that are unknowns, go back through your rules to determine one of those. You will only have one unknown to solve for in a particular problem. Calcium nitrate is our next example. Calcium is a metal, so it will have an oxidation number of +2, which is the same as its ionic charge in a compound. Nitrogen is again our unknown, and oxygen is a -2. We can set up our equation with +2 plus 2 times X because there are 2 nitrogens, plus 6 times -2 because there are 6 oxygens. The sum of these oxidation numbers will equal 0. We can simplify this to 2 plus 2x minus 12 equal to 0, 2x minus 10 equals 0, 2x equals 10, and x equals 5. So the oxidation number of nitrogen in this compound is +5. Note that in each of these examples, nitrogen has a different oxidation number. In this set of examples, we will see the different oxidation states or oxidation numbers that can be had by chlorine. Starting with our first HClO3, we see hydrogen has a +1 oxidation number, chlorine is our unknown, and oxygen has a -2. So +1 plus x plus 3 times -2 will be equal to 0 because it's a neutral compound. 1 plus x minus 6 equals 0, x minus 5 equals 0, and x equals 5. So the oxidation number of chlorine in HClO3 is 5. Our next example is Cl2O7. Although this is a binary compound, this is an example of a time when chlorine will not be -1. We know this because if the oxidation number of chlorine were -1, we'd have a total of -2, and we know that oxygen must be -2, which would have a total of -14, and we would not get a sum equal to 0. The rule for oxygen is higher in the list, and we would already have assigned the oxidation number of oxygen as -2 before we would get to the rule that pertains to halogens. So chlorine will be labeled as our unknown. Oxygen is -2. We have 2 times x plus 7 times -2 equal to 0. 2x minus 14 equals 0. 2x equals 14, and x equals 7. So the oxidation number of chlorine in this compound is +7. Another example is Cl2O, also a binary compound, but does not follow the rule for chlorine being a -1, because we know that oxygen is also a -2 oxidation state, and we know that the sum of the oxidation numbers must be equal to 0. If I have two negative values, they can never equal 0. Again, chlorine will be our unknown. Oxygen will have -2. We have 2x plus -2 is equal to 0. So 2x equals 2, and x equals 1. So chlorine has an oxidation number of +1. Again, we have 3 different compounds, all that contain chlorine, and all have a different oxidation number. Now we will look at a series of examples with hydrocarbons. There are no rules pertaining to the oxidation number of carbon, so it will be our unknown. So we have X for carbon and plus 1 for hydrogen. X plus 4 times 1 is equal to 0 because we have a neutral compound. X equals minus 4. For C2H6, carbon is still our unknown. Each hydrogen is plus 1. So we have 2 times X plus 6 times plus 1 equal to 0. 2x plus 6 equals 0. 2x equals minus 6, and x equals minus 3. For C2H4, we use X for the oxidation number of carbon. We know that the oxidation number of hydrogen is plus 1. So 2 times X plus 4 times plus 1 is equal to 0. 2x plus 4 equals 0. 2x equals minus 4, and x equals minus 2. So the oxidation number of carbon in C2H4 is minus 2. 3 different compounds, all containing carbon and hydrogen, and in each case carbon has a different oxidation number.